2, 3, 4. Can I start now?
Yes, Mr.
All right. So I'll just quickly revise the topic on electrolytic cell. You just have to know the parts of the electrolytic cell, and then we'll go on to the application of the electrolysis. So again, for the electrolytic cell, you have the flow of current is from not flow of current, the flow of electrons is from positive to negative. The anode is the positive electrode. The anode is the positive electrode, and the cathode is the negative electrode. All right. Now, the flow of ions, positive ions are the cation ions, and the negative ions are the cation ions. Positive ions are the cation ions, and the negative ions are the anions. When the current is switched on the anions, the negative ions, they will move to the positive electrode. So negative ions will move to the positive electrode. Anions, which are the negative ions, they will move to the anode, which is the positive electrode. And the cation, which are the positive ions, they will move to the negative electrode, which is the cathode. All right. Now, I have also placed a diagram here. And when we are looking at electrolytic cell, we must be able to identify the parts of the cell as what I've explained. And you must be able to write a half equations for the reaction occurring at the anode and at the cathode. All right. Now, this is an example of an application of the electrolytic cell. But for the topic on electrolytic cells, we will look at electrolysis. And under electrolysis, we will look at electrolysis using inert electrodes and electrolysis using reactive electrodes. And this will be the final topics on the unit 12.3. So for the electrolysis of inert electrodes, we will look at electrolysis of molten salts and aqueous salts. And for the reactive electrodes, we will look at electroplating and metal refining. But for today, we'll try to cover electrolysis of molten salts and aqueous salts if we have time. Now, electrolysis is the breakdown of a substance using electricity. And electrolysis is the process, and the process occurs in a cell. So electrolysis takes place in an electrolytic cell. All right. And our first topic, subtopic for electrolysis is the electrolysis of molten salts. All right. And again, I always like to tell you what you're supposed to know by the end of the lesson. So you must be able to understand and describe the setup of the cell that is used in the electrolysis of molten salts, write half equations of the reactions occurring at the anode and at the cathode, and you must identify the products that will be formed at the anode and at the cathode. These three things are the ones that are constantly tested in the examination. Writing half equations at the anode and at the cathode, identifying the products, and also understanding how the cell works or operates. Now, for the electrolysis of molten salts, as it shows in the name, salts are substances that are formed from metals and non-metals, all right? So salts are ionic compounds, and ionic compounds cannot conduct electricity in the solid state. They can only conduct electricity in aqueous or molten. So here we are trying to see how salts will conduct electricity as or in the molten state. But before we look at that, let's look at the setup of the cell. Let us look at the setup of the cell that is used in the electrolysis of molten salts. So we have the positive electrode. We have the positive electrode here. We have the negative electrode. And we have the electrolyte. Now for the electrolysis of molten salts, the electrolyte is actually the molten salt. So the salt has to be melted, and the molten salt is the electrolyte. Now, this is what I explained earlier on. The salt is an ionic compound, and it can only conduct electricity in a molten state or as a solution in water. So for this case, heat energy will be needed to melt the salt. The salt will be in the molten state, and then electrical energy will be passed through the molten salt. When electricity is passed through, then a chemical reaction will take place. So when electricity is passed through the molten salt, then the cations will move to the cathode. The cations will move to the cathode, and the anions will move to the anode. So the positive ions will move to the negative electrode, and the negative ions will move to the positive electrode. So you must be able to identify which ions will move to which electrode. And then when the ions move to that electrode, you must be able to write the half equation starting with the ion, and then you have to identify the product. So the ion will move to that particular electrode, and it will form a product. The cation will move to the cathode and form a product, and the anion will move to the anode, and it will form a product. So you should write the half equation, and you should also identify the product that will be formed. If you have any say, I just allowed you to unmute yourself. You can unmute and ask, and then mute yourself again. All right. Now, let's go back to what we're discussing. So, we are looking at the electrolysis of molten salts using inert electrodes. And I said that the salts can conduct electricity when they are in the molten state. So when electricity is passed through, cations will move to the cathode, and anions will move to the anode. All right. And the electrodes are inert. They are not taking part in the reaction. The electrodes are inert. They are not taking part in the reaction. And the materials, the preferable materials that are used to form those electrodes are graphite or platinum. So do not get confused with writing half equations for the electrolysis of molten salts by using the materials that make up the electrodes in the half equations. This is a common mistake with students, that they will use the platinum in the half equation. No, that's wrong. All right. So let's look at an example. Let's look at the electrolysis of molten sodium chloride. All right. Now, sodium chloride, the salt, has to be melted first, as you can see in the diagram. And once heat is applied, then electricity will be switched on. All right. When the source of electricity is switched on, then the reaction takes place. And how many ions does molten sodium chloride has? Molten sodium chloride will have only 2 ions. All right. It will have Na plus and it will have Cl minus. All right. So sodium chloride, molten sodium chloride will have Na plus and Cl minus. And when the current is switched on, the Na plus, which is the cation will move to the cathode. The cation will move to the cathode, and the anion will move to the anode. So Na plus will move to the cathode, and Cl minus will move to the anode. And when Na plus goes to the cathode, it will form sodium metal. So the product will be sodium, or just Na. And Cl minus, when it moves to the anode, it will form chlorine gas. And we have to write half equation, right? My apologies. Now, when Na plus goes to the anode, and by now you must know how to write half equations, you should see that both half equations should begin with the ion. All right. So from here you should see that the Na plus goes to the anode, or the Na plus goes to the cathode, and the process of reduction occurs at the cathode. So Na plus plus electrons will give you Na, and at the anode, Cl minus will move towards, and it will form, or it will be oxidized, and it will form chlorine. So you must be able to write these half equations, and you must also be able to identify the product. So for the electrolysis of molten sodium chloride, the word molten is the keyword here. The word molten should tell you that there are only 2 ions involved. There is Na plus for sodium and Cl minus for chlorine. Na plus will move to the cathode and will be reduced. It will gain the electrons to form sodium metal, but the state is liquid because it's in molten state. And chlorine, the chloride ion, will move to the anode, and it will be oxidized to form chlorine gas. To write the overall reaction, You simply collect the reactants. You can write Na plus Cl minus will give you Na and Cl2. You omit the electrons. Or Na plus and Cl minus, it will form NaCl, so you simply write 2 NaCl. All right. I have these other examples. And again, when you are confronted with an exam question, the keyword is molten. So when you see the word molten in the question, then when you see the word molten in the question, then you must know that two ions are involved. And with two ions, the cation will go to the cathode and the anion will go to the anode. So the cation, which is usually the metal ion, it will move to the cathode and it will form the metal. And the anion, which is usually the non-metal, it will move to the anode and it will form the non-metal part of that ion, of that salt, sorry. So in the first one here, we have calcium chloride. The two ions that will migrate to different electrodes are Ca plus, Ca2 plus, and Cl minus. So the Ca2 plus will move to the cathode and it will form sodium metal. So one of the possible questions in the exam will be to identify the products, like as in this table that I've shown. So the product at the cathode for calcium chloride will be calcium metal, and the product at the anode for calcium chloride will be the chlorine gas. So you can write chlorine gas or you write a symbol, but when you write a symbol, you have to write it as Cl2, which denotes a gas. If you write Cl, you might be marked wrong because Cl is an atom. All right. So basically, the metal ion moves to the cathode and it will form the metal, and the non-metal ion will move to the anode and it will form the non-metal. So calcium chloride, calcium is the product at the cathode and chlorine will be the product at the anode. All right. Let's continue. Sodium iodide. For sodium iodide, the product at the cathode will be sodium metal. All right. Again, there are only two ions, so sodium is the product at the cathode and iodine will be the product at the anode. All right, let's continue. So for lead oxide, again, if we are looking at the electrolysis of molten lead oxide, then the product at the cathode will be the metal, and the product at the anode will be the non-metal. I'm not getting any feedback. How do I make sure the students are with me?
You want to see the students are with you or not? You want them to ask questions?
Yeah.
Here. You can see them. Talk to them.
All right. Do you have any questions so far? I'd like to move on to electrolysis of aqueous salts. You have to unmute and ask a question so I know we are all together.
No question, Mr.
Emmanuel?
All good, all good.
All good.
Yeah, I think so. That's why they're not asking any questions. All right. So let me just summarize electrolysis for molten salts. We have around 8 more minutes to go. Now, again, the application of the electrolysis. For electrolysis, we will look at molten salts, aqueous salts. That's inert electrode. Electrodes are not taking part in the reaction. And then when we look at metal refining and electroplating, that's when the electrode will take part in the reaction. So for the electrolysis of molten salts, there are only two ions involved: the metal ion and the non-metal ion. And from the examples that I explained here, for example, calcium chloride, when the electricity is passed through molten calcium chloride, the Ca2 plus ions will move to the cathode and the Cl minus ions will move to the anode. That's the first thing you must know. Then you must know that when Ca2 plus goes to the cathode, it will form calcium metal. That's another common exam question, identifying the product. And when Cl minus goes to the anode, it will form chlorine gas. So electrolysis of molten salts is pretty straightforward. I'll just try to write some half equations, but I don't know how I'm going to move from this. How I'm going to move from this screen to the smartboard. Let me just try it out first. All right. I can't. How will this screen appear on the board for me to write this one? Maybe I'll just close this. Why is
Ask Mr. Oz.
this one? It's not appearing on the. It's not appearing on the board. Anyway. Anyway, I cannot I cannot write on the smart board. So if we are looking at calcium chloride, for example, then at the if we are looking at calcium chloride, for example, then at the anode, if you're looking at the calcium chloride, for example, then at the anode, then you will start a half equation with the ions. So Cl minus is at the anode, it will lose the electron and it will form Cl plus electron. But we have to balance this because chlorine exists as a gas with Cl2, and then the half equation becomes this. All right. So this is the half equation, but the product is actually this, the chlorine gas. At the cathode, we will have Na plus ion. So you can see that the half equations are starting with the ions, and at the cathode there'll be reduction. So Na plus plus electron will give you Na, right? So these are the things that you are supposed to do. You must be able to identify the ions that will go to the electrodes, right? The half equations at each electrode, and identify the products. All right. And I have allocated some work for you. And you can also consult your question bank to solve some of these questions. I will improve the next time when I talk about aqueous salts. Thank you very much.
Thank you, Mr.